Let's start doing some real coding in Python and see how you compute the mean, median, and mode using Python in some IPython notebook file we have. Okay, so open up the mean, median, mode notebook from your course materials over here on your Jupyter Notebook page here. And again, if you do need a refresher on how to do that, head back to the setup lecture and I'll show you how to do that again. But once you have mean, median, mode open, we can play around with it. So let's see what's going on here. So what we're going to start off doing is creating a fake data set of income distribution. So we're going to model 10,000 people and how much money they make each year. Now to do this, we're going to use the NumPy package. So like we talked about in importing packages in our introduction to Python, we'll start off by saying import NumPy as NP. This allows us to refer to the NumPy package as just NP, which just saves us some typing in addition to importing that package so we can use it. Now the NumPy package includes a function called random.normal, and what this does is create a random distribution. Basically, it creates a bell curve distribution of data around a certain point, in this case $27,000, with a standard deviation of $15,000, and we want 10,000 data points in this data set. Now, if you're not familiar with standard deviation and normal distributions, we will talk about that in more detail later on, but I think you'll start to make sense of it as you go through this exercise. So once we've created that data set of 10,000 people that have a distribution centered around $27,000, we can then call np.mean to use the NumPy package to compute the mean or average of that data set. And since we specified that it should be centered around $27,000, we would expect that to be about $27,000. So let's click into this block of code and hit Shift-Enter to run it. And sure enough, it is about $27,000. Now, because there is a random component to this, your result may be slightly different. That's expected. That's okay. But it should be close to 27,000. So we can actually plot this to get a more intuitive feel of how this data is distributed. To do that, we're going to use a package called matplotlib, which allows us to create really simple graphs here in line. And to actually display these graphs within the notebook file itself, we need to say %matplotlib inline as the first line here. Now, if you ever run into a problem in the future with this course in the notebooks where your graphs aren't displaying, it's probably because you forgot to run a block of code that contained matplotlib inline. That is required to actually see these graphs. With that out of the way, though, we can import the actual matplotlib package itself, specifically the pyplot part of it. And again, we'll refer to that as an alias of plt just to save us some typing. So now that we have matplotlib's pyplot installed, we can just say plot.hist to create a histogram of our incomes data set, and we're going to pass in the number 50, meaning that we want this split up into 50 different buckets. So we're going to quantize our data set into 50 discrete buckets of data, if you will. And then we can call plot.show to actually show it. Let's go ahead and run that as well. Shift-Enter within that block. And you should see something that looks a little bit like that. So there's that bell curve that I promised you, right? And you can see that it is centered around $27,000 or so. If you're not familiar with histograms, the way to interpret this data is that a lot of people are making around $27,000 a year. Very few people are making between $60,000 and $80,000 per year. Okay, so that's the fictitious data that we made up. So we've seen that the mean is about $27,000. That makes sense. That's what we would expect. What's the median? So again, the median is just, if we were to sort all this data, what would be the value in the middle of it all? And since we do have a nice even bell curve distribution here, the median should be about the same as the mean. Let's go ahead and click in block 3 here and run that, Shift-Enter. And sure enough, that's also about $27,000. So for an evenly distributed data set like this, the median and the mean will be about the same. However, not every data set is evenly distributed. Let's see what happens if we add Jeff Bezos into the mix. And let's just say that he made $1 billion last year. It's probably a little bit on the high side even for Jeff Bezos, but just for the sake of argument, we're going to call np.append to just append one extra value to the incomes list, and it will contain the single value 1 billion. So we'll have a new incomes list here that contains our normally distributed data plus Jeff Bezos there to mess things up. Now remember, the median just represents what's the middle value if I were to sort them all. And we've only added one more data point here, so that shouldn't change a whole lot, right? So let's run the median again. And we're still getting a value close to $27,000. So Jeff Bezos did not mess up the median of our data set. However, if we compute the mean, it's going to be very different, right? That's up to like $127,000 almost. So this is a great story about how an outlier in a data set can really mess up the mean or the average value of that data set. So when people talk about averages or means, take that information with a grain of salt. Ask yourself, could there be outliers that are skewing that data? And income distribution is a great example of this. In that case, the median is going to tell you a better story about what's really happening in the larger population. So, statistics lesson number 1, or how to watch out for people lying with statistics, make sure you understand the difference between median and mean, and if there are outliers involved, the median is probably going to give you more useful information. We'll also touch on mode, just because it starts with M and people talk about it together with mean and median for some reason. So let's go ahead and create another fake data set here. This will be evenly distributed. We'll have a bunch of fake ages for 500 people, so we're going to call np.random.randint to have an even distribution of between 18 and 90 years old for 500 people. And then we'll just type in ages, which allows us to visualize that array in line here. Shift-Enter within that. And this is random, so we're going to get different results every time. Now to compute the mode, again, that's just the value that appears most often in this data set. So let's go ahead and do that. To do that, we're going to use the SciPy package and its stats module. And this is just another way of importing it. So we're saying from SciPy import stats. In this case, we're not going to use the as clause because I can type stats. That's not too hard. And then we will call stats.mode on the ages array to get back our mode result. And after that chugs away for a little bit, it's got to load up that package. We get our answer. Turns out in this instance, the mode is 28, which occurred 14 times in this data set. And this is completely random, so every time you run this, you will get a different answer. Let's go back up to block 7 here again and Shift-Enter again to get a fresh data set here. And if we run this block 8 again, we should get a different answer. This time the mode is 20, which occurred 15 times. So just shows you that the mode works, but this is random data, so it's not terribly meaningful, but illustrates how you would do this in SciPy. All right, so there you have it, mean, median, and mode. Let's move on to an exercise to let you practice with it. I'm going to give you a little assignment here. If you open up mean, median, exercise, IPython notebook, there's some stuff you can play with. So I want you to roll up your sleeves and actually try to do this. Here we have some random e-commerce data. So what this data represents is the total amount spent per transaction. And again, just like with our previous example, it's just a normal distribution of data, just like our income example. You can run that. And your homework is to go ahead and find the mean and median of this data using the NumPy package. Pretty much the easiest assignment you could possibly imagine. All the techniques you need are on the mean, median, mode IPython notebook. My point here is not really to challenge you, it's just to make you actually write some Python code and convince yourself that you can actually get a result and make something happen here. So go ahead and play with that. If you do have any trouble, post in the discussions for this lecture and we'll help you out, but it should be pretty trivial. If you want to play with it some more, feel free to play around with the data distribution here and see what effect you can have on the numbers there, and add some outliers, kind of like what we did with the income data. So mess around, that's the way you learn this stuff. Have at it, have fun. All right, I hope you rolled up your sleeves and actually played around with that code a little bit, get some confidence in actually doing statistics in IPython notebook there and Python in general. So with that behind us, let's move forward to our next concept, standard deviation and variance.